Hello students, this is Dr. Intra, your chemistry mentor, welcoming you for another session in chemical bonding. So today we are going to see about the hydrogen bonding, that too the nature of hydrogen bonding and its types. Okay. By the way, what do you mean by hydrogen bonding? Actually, a hydrogen bond is formed through hydrogen atom between any two highly electronegative atoms of small size. So before saying this hydrogen bonding, you should know what is electronegative atom. Okay. See, actually, electronegativity is nothing but it is the tendency of an atom or a functional group to attract electron towards itself. Can you understand? So electronegativity is nothing but it is the tendency of an atom or a functional group to attract electrons towards itself. Okay. So this hydrogen bond is formed through hydrogen atom between any two highly electronegative atoms, and that should be also of small size. Okay. See here, this is hydrogen bonding, and here X and Y are considered to be highly electronegative atoms. Okay. See here, we could see this hydrogen in between these two highly electronegative atoms. Actually, in other words, when hydrogen atom is covalently linked to a highly electronegative atom and is bridged to another highly electronegative atom, the bridge formed is known as hydrogen bond. Can you understand? See, this hydrogen bond is already covalently linked with this highly electronegative atom, and this hydrogen is again bridged to another highly electronegative atom, and this bridge is known as hydrogen bond. Actually, this hydrogen bond is considered to be little weak when compared to a covalent bond. Okay, can you understand? Now we shall see the conditions for the formation of a hydrogen bonding. Okay, so the important conditions for the formation of hydrogen bonding are: the first one is highly electronegativity. In high electronegativity, the atoms that are participating in hydrogen bonding should have high electronegativity. Okay, and the next condition is it should be of smaller size. Okay, the atoms should be of small size. Okay, the participating atoms should be of smaller size. And also it should have high electronegativity. Actually, this fluorine, then oxygen and nitrogen are the only atoms with small size and high electronegativity. See, these two criteria are satisfied by fluorine, oxygen and nitrogen. Okay. So hence they can take part in hydrogen bond formation, this fluorine, oxygen and nitrogen. But when you are taking into consideration chlorine, see, chlorine is also an atom with high electronegativity, but this cannot easily form hydrogen bond. It has a less tendency to form hydrogen bond due to its a bigger size. See, the atomic number of fluorine, it is 9, whereas nitrogen it is 7, whereas oxygen it is 8. Okay, so the atomic number is the small atomic number, and obviously the size will also be smaller, whereas chlorine atomic number is 17, so obviously its size will be larger. Okay, so the distance between the nuclei and the valence shell will be little higher when compared to fluorine, nitrogen and oxygen. So since the electronegativity of the atom is affected, okay, by both its atomic number and also the distance that its valence electron reside from the charged nuclei. Okay, so this is the reason why this chlorine is not able to form a hydrogen bond when compared to this fluorine, oxygen and nitrogen, whereas these elements, these atoms, they can easily form hydrogen bonding. Okay, so these are the important conditions for hydrogen bonding: high electronegativity and small size. Can you understand? So next, let us see the nature of hydrogen bonding. Okay, see, actually this hydrogen bonding is electrostatic in nature. Okay, this hydrogen bond is electrostatic in nature and is observed only in polar molecules. Okay, only in polar molecules. Okay, so they should have, the molecule should have positive negative charges. Okay, so hydrogen bond is electrostatic in nature and is observed only in polar molecules. Let me explain with a simple polar molecule, that is HF. Okay, formation of HF, right? See, I have shown the structure of the molecule of HF, okay? See here, this fluorine is more electronegative than hydrogen. So, the electron pair binding the two atoms, okay, will be shifted towards fluorine. Okay, since what do you mean by electronegativity? It is the tendency of an atom to attract the electron pairs towards itself, okay? See here, this fluorine is considered to be highly electronegative. So what happens is the electron pair that is binding this fluorine and hydrogen will be shifted towards a fluorine so that this fluorine gets a negative charge. Since the electrons are shifted towards fluorine, this fluorine will be getting a negative charge and this hydrogen will be getting a positive charge. Can you understand? Now, this positively charged hydrogen atom attracts the electronegative atom present in another molecule. See this one is next molecule, this one is another molecule. So this hydrogen, positively charged hydrogen atom, it attracts the electronegative fluorine atom, okay, present in another molecule, thereby forming a hydrogen bond. Okay, see here already we knew that this fluorine is electronegative. So what happens? This positive charge attracts the electronegative atom present in another molecule, thereby forming a hydrogen bond. Okay. So here this will be getting a positive charge again, right? So this will be going on continuously. So hope you might have understood this point from this example, that is hydrogen bond is electrostatic in nature and is observed between polar molecules. Can you understand? So the next nature, okay. So next one is, see here, this hydrogen bond is found much weaker than covalent bond. So I already told you, is it not? See, the energy of the hydrogen bond is found to be in the range between 10 to 40 kilojoules per mole. Okay, okay, this is for mole. This is for hydrogen bonding. Okay, but when you are taking into account the covalent bond, the energy is little high. Okay. Another point coming under this one is, since fluorine is highly electronegative than oxygen and nitrogen, it forms stronger hydrogen bond than those of oxygen or nitrogen. Okay. So let me show this. See here, I have given the formation of hydrogen bond between different molecules. See here, this fluorine, the energy released is 28.5 kilojoules per mole, whereas for oxygen, hydrogen bond formed between hydrogen and oxygen, it is 18.8 kilojoules per mole. Okay, and for nitrogen, the energy released is 14.2 kilojoules per mole. So from this you can understand that since fluorine is more electronegative than oxygen and nitrogen, it forms stronger hydrogen bond than those of oxygen and nitrogen. Next we shall see the types of hydrogen bonding. Actually there are two types of hydrogen bonding and they are intermolecular hydrogen bonding and intramolecular hydrogen bonding. Okay, so two types of hydrogen bonding, intermolecular hydrogen bonding and intramolecular hydrogen bonding. So let us see the first one, that is intermolecular hydrogen bonding in detail. So what does this intermolecular hydrogen bonding mean? Actually, this type of bond results between positive and negative ends of different molecules of same or different substances. Can you understand? So, this type of hydrogen bonding exists between the positive and the negative ends of different molecules of same or different substances. Okay. So, let me explain with the example this hydrogen fluoride. See here, this is one molecule, this is another molecule, and this is another molecule. See here, this is the negative end, this is positive end. Okay, so this type of bond is found between the positive and the negative ends, the positive and the negative ends of different molecules of same or different substance. This is the same substance. Okay, so now we are seeing the intermolecular hydrogen bonding formed between the different molecules of same substance. Okay, different molecules of same substance. Okay, see here, this is negative and this is positive. Okay, and this is negative, positive. So negative, positive, like, okay, then negative. So this intermolecular hydrogen bonding, here the positive and the negative ends of different molecules of same substance is seen here, intermolecular hydrogen bond. This is also an example of the same category. So same substance, that is water. This is water molecule, H2O, H2O. This is okay, H2O. Here also, then again H2O. Okay, so different molecules. Here also, we could see the hydrogen bonding between the negative and the positive ends of different molecules of the same substance. Now I am going to show you the hydrogen bonding between alcohol and water. Okay, alcohol and water. So this one here, the positive and negative ends of different molecules of different substance we are going to see. Okay. So I have given the structure of the intermolecular hydrogen bonding between alcohol and water. Okay. So this is H2O. H2O. This is alcohol. Okay. See here, the negative end of alcohol is combined with the positive end of the water. So this, so the positive and the negative end of different molecules of different substances. So this is ethanol. This is water. So this is an example for intermolecular hydrogen bonding seen in different molecules. Okay. So next we are going to see the consequences of this intermolecular hydrogen bonding. Okay. First one is the increase in boiling point and a solubility. So actually this type of bonding increases the boiling point of the compound and its solubility in water. The reason is the increase in boiling point is due to the association of several molecules in the compound. For example, see here why the boiling point is increasing. See, this water molecule is linked with another water molecule and again through intermolecular hydrogen bonding and again linked with another. So it requires a high temperature to break the bond. It requires temperature to break the bond. Okay. So that means the boiling point will be getting increased. We should supply more amount of heat energy to break the bond. Only then the substance will be getting boiled. Okay. And the next point is increased in viscosity. See here, if intermolecular hydrogen bonding is there, then the viscosity will be high. Okay. See here, the intermolecular hydrogen bonding is also responsible for the increase in viscosity. What do you mean by viscosity? Is the restriction offered to for the flow of a liquid. Okay. Greater the extent of hydrogen bonding, more will be the viscosity. Greater the extent of hydrogen bonding, greater the hydrogen bonding, more the viscosity will be. For example, let me give an example, CH3, CH2OH. So this is ethyl alcohol. The viscosity is 1.2 Cp. Cp is nothing but centipose. Okay. And next CH2OH, then again CH2OH. So we are having two hydrogen bonds. Okay. So this one viscosity is equal to 17 centipose, right? And then glycerol. This one is ethyl alcohol. This is glycol. Okay, ethylene glycol. Next one is glycerol. So CH2OH, CH2OH. See here, its viscosity is found to be 1070 Cp centipose. Okay, so as the hydrogen bond increases, the viscosity is going on increasing. This shows that intermolecular hydrogen bonding is also responsible for the viscosity, greater increase in viscosity. Greater the extent of hydrogen bonding, more will be the viscosity. Can you understand? Next, intramolecular hydrogen bonding. This type of bond results between the hydrogen and electronegative element both present in the same molecule. So this type of intramolecular hydrogen bonding is formed between hydrogen and electronegative element of the same molecule. See here, this is orthonitrophenol. So here we could see the hydrogen bonding between the OH group of orthonitrophenol with the nitro group, oxygen of nitro group. So we could see the hydrogen bonding within the molecule. Okay. Here salicylaldehyde. Here also, see this is OH group and this is aldehyde group. So hydrogen bond is formed between the oxygen atom of this aldehyde group as well as the hydrogen atom of the OH group. So we could see this type of intramolecular hydrogen bonding between the hydrogen atom and the electronegative element that is present in the same molecule. Now, are you understood the difference between intermolecular and intramolecular? Okay. This type of bonding is generally present in organic compounds. Okay. So both are organic compounds. So now we are having some consequences here too. So consequences of intramolecular hydrogen bonding. See, decreased boiling point and solubility. This type of bonding decreases the boiling point of the compound. The reason for this point is we could see the hydrogen bonding within the molecule, not outside. Okay, it's not formed between different molecules of different substance or same substance, but it's within the molecule. That is hydrogen and all electronegative element of the same molecule. So it's enough if you spend little amount of temperature for the substance to get boiled. Okay, that's why the boiling point is decreasing. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic, that is the consequences of hydrogen bonding, in my next video. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from it. Thanks for watching.